So, welcome everybody. I know this is the last session of the event, and I really appreciate all you guys coming here. My name is David Saah, and as you can see from this huge list of folks, I'm part of a large effort here. And what we're hoping to do today is to go through a couple of the different things. We want to give you guys an overview of Servir for those of you who aren't familiar with it. It's a pretty amazing program. We want to talk to you guys a little bit about the way that we operate. Severe is a little bit different than the traditional USAID or NASA project or program. We're going to give you some insights on how that actually works. And last year, what we did was that we went through very briefly all the different tools and services that we were delivering through the hubs, which was great because we got a lot of really excited folks about a lot of the code that we had and the tools that we were building. But it seemed like we didn't have enough room for conversations. And so the last thing we want to do for today is really enable us to have a dialogue, break out into smaller groups if interested, we want you guys to take and learn and contribute to some of the efforts that we actually have. Does that sound like a plan? Yay! And in the title, we got stickers. Um, all joking aside, we have a bunch of stuff here for you guys to take. Everyone likes the meatball, including me. I look like a meatball. But take it, use it, distribute it. Okay. So what is Servir? So Servir is a joint program between USAID and NASA. It's a real collaboration between those major organizations. And the real idea, the purpose, the goal of it is to take space-based technologies. The tagline is take space-based technologies down to village-level decision-making to make an impact. And what does that actually mean? Does that mean that we're going to actually take a satellite and give it to a villager, hoping that they're going to be able to improve their farming? No. The idea is to be able to take Earth observations, the analytics associated with Earth observations, and make that village or that community more informed about the choices that are being made for them or the choices that they're actually making in order to have a more sustainable future, right? That's the goal, that's the vision. And there's a variety of different service areas that we work in, and you're going to hear us talk a little bit about service because we see this whole program as service to a community, service to the environment, and we have a service delivery framework in mind. And the places that we work is agriculture and food security, right? Think about all the things around that. And I know we've had a lot of talks this week about that. There's a whole land cover component. We had a lot of talks about that. Waters and disasters, lots of talks about that. Weather and climate. So all the tools that we've been hearing about all week, all the things that you could do with Earth Engine and the Google technologies fit really nicely into all the major services that we're thinking about. Now, where do we work? Where is the Severe program? How does the Severe program actually organized? Right now, we have 5 hubs. We have one in the Mekong region. We have one in the Himalaya Hindu Kush. We have one in East Africa, one in West Africa, right? Africa's humongous. You need 2, right? And then we just launched one right now. When I say we, this is the global we, not me, we. Launched one in the Amazon. And there's also another effort being launched right now in Central America as well. So if you look at this, it's a large part of the planet that really needs these technologies to help them improve decision making. It's not a NASA drop program. It's not a USAID drop program. The people that are actually implementing these projects are usually consortiums in some examples or institutions that have been in the region for a long time. So it's really enabling local folks to do things. And what we're really trying to do is we're trying to bridge this gap. And you guys, I mean, we've had this conversation, I don't know how many times over coffee, but you got the science folks and you got the end user needs and that last mile or that keystone brick or that gap in this bridge is oftentimes missed. And what we're really trying to focus on is actually connecting this part so we can have a continuum of information flow, knowledge, and hopefully impact. And we do this by leveraging the science, right? All kinds of cool satellites. And, every day this spectrum, this constellation is changing in a bunch of dynamic ways, right? To take advantage of all kinds of data that looks like this, right? Imagine being able to see the whole planet live on an ongoing basis with technologies like Planet and some of the new stuff that's coming out. This is doable, right? And this one, if you look at this one, is it actually showing up? I'd have to push it again. Oh man, darn it! Go. So if you did see, you will make the slides available, but when you run it on your local machine, what you would see is an accumulation of precipitation in real time. So like some of the new sensors are actually capturing that information as well. So imagine being able to take all that data and all that science and putting it together to fit the end user need. Now, the way that we actually do this is going to be discussed by Tim. You want to get up here and talk about this? How do we do it?
So Servir is very interesting in the way that we approach the services themselves. So the model that Servir uses is really to generate these services through a service planning framework. So there's three main steps that go into that. So it really centers on the collaboration with stakeholders. So doing needs assessments and identifying and prioritizing what those development challenges are, and really focuses on designing a tool or a service that is detailed. So that way, you're, as David had mentioned, with the service and the end users, often people like to come in and just make a tool. But that's not our approach at all. So we want to start from the very beginning and do those needs assessments and lay out all the components that go into that service design. And then the final component of that is the actual implementation. So making sure that we have sustained efforts in the region, and when we're releasing or implementing some of these tools, we're there, and the hub members are also there to make sure that it's being addressed and taken into adaptation and is being utilized by the end user. So it's a cyclical process, but you can see as it moves across, there's that first needs assessment and then service design and delivery. Those are the main staples of this framework. So we really like this idea, and we've implemented it now across all of the hubs. Here's just an example from the Mekong's website. So when we say a service, it doesn't necessarily have to be just a geospatial tool, for instance. Sometimes we like those, but it could be something like technical consultation or training or capacity building. That's another example of some of the needs assessment that once we do a needs assessment, we go in place and do some of those as well. So it could be data sets, tools, capacity building trainings, or technical advice. So those are some of the components of the things that we do at Servir. So with that being said, you have kind of an idea of the model now. We're going to go into some examples from all the folks who are here from Servir, and we can move to the cafe discussion as well. So here's the first example from the Mekong.
Why don't we talk about our format?
Yeah.
So leave it right there. So the way that we're going to do this is we're going to invite a representative from each of the hubs to come and give us a couple-minute example of some of the service designs that they're doing. And then afterwards, let's hold the questions, because we're going to break out into little subgroups where you could actually dig in and grab the code and understand what they're actually doing. Does that sound like it's okay with everybody? All right. So the first example, let's bring in the Mekong group. Biplov, yay! Give Biplov, yay, Biplov.
Thanks. My name is Biplov. I work as a GIS and remote sensing developer for the Servir Mekong project. So one of the services that we have been delivering to the 5 countries in the Mekong is the regional land cover monitoring system. So interesting idea with this system is that it's based on the primitive layers. So primitive layers are the biophysical layers, and we have these, I think, more than 15 classes. And then the beauty of the system is that each of the country can then use those primitive layers to design their own land cover system. So as you can see the, oops, sorry.
The laser beam on the bottom.
Okay, so once you have the primitive layers, then we invite the stakeholders from different countries to design their own land cover system and use those primitive layers to generate the final assemblage classes. So this is one of the main services that we have been working on. Please go and explore the system and play around in this website given below, and the methodology is explained there. Thank you.
You want to do CEO? The collector at the, I'll do collector at the line. So Can I add to your slide just a little bit? So if you look at the bottom, there's two URLs. The regional land cover monitoring system is probably an hour-long conversation. If you want to go to the URL, you could see how we actually do land cover monitoring at scale. It has all the code. It has the way that we put stuff together. It even has the code to build this interface. If you wanted to take this and take off our names and put your names on there, feel free to do so. Okay. The other challenge that we had when building land cover monitoring systems, just in general, is collecting ground reference data. How many of you guys have problems with collecting reference data? One, I see. Two, come on, people, tell the truth. Collecting reference data is hard, right? And so what we ended up doing here is we ended up striking a collaboration with FAO, the UN's Food and Agriculture Organization, to piggyback on top of their Collect Earth system, where we're able to take that. I don't know if you guys have ever played with it. Is to take that platform and turn it into an online platform where we could crowdsource a series of experts to collect information that we would need to map out different things that we put together for land cover mapping. What's nice about it is that that tool was built specifically for the land cover monitoring system for us, but there was a knock-on effect where they actually ended up, they being FAO, ended up taking that tool and now they're using it for their global forest resource assessment. And they're collaborating with it. So it's another example where we co-design and co-develop these products with folks that are able to pick it up and use it on their own. The next set of examples that we have come from West Africa. Come on up.
Okay, good morning, everybody. I'm Saliu, User Engagement Lead, and I'm with...
Okay, I'm Abena from Ghana.
Okay, I will just give you a quick overview of what we're doing at West Africa, and Abena will go in more detail in one of the services we're working on. In West Africa, we are working under these four focal areas. We have developed different services. Under the weather and climate, we are working on developing a service for dust management. It was a requirement from the UNCCD we are working with. Under the water resources, we have a service dealing with ephemeral water bodies. It's a need for elders in the federal region, and we're working with the Centre de Suivi Écologique to develop a service into this one. We have another service also dealing with groundwater monitoring. We are working on with Argument, trying to map out groundwater resources in two regions in Niger, in Tillabéri and I don't know the other region, but it's in two regions in Niger. The other service we are working on in collaboration with FAO and CSLPRO is locust monitoring. We're trying to develop an early warning tool, trying to prevent locust outbreak in the region. And this is an important service covering the West African region. We're working with FAO. And under the land use, land cover, we have different services we're working on. And here we're collaborating with the UNCCD. And we presented the report we draft for the UNCCD for the West Africa region. We presented at the last CUP at New Delhi. And now we have been asked by UNCCD to develop a series of map of land vulnerability to droughts. This is one of the services we'll be working on. And we are working also on illegal mining, and Abena will present in detail that service. Also, with the same institution, we're working also on charcoal production. I will let Abena present this.
Thank you very much. So, talking about illegal mining in Ghana, what mostly happens is that these people are mining along river bodies or along rivers, and then they're also mining into protected forest areas. So, you realize that people are cutting down trees along these protected areas and then these forest reserves. And what we have here projected is radar image from Sentinel-1 that was captured from 2015 to 2019. And so we set a threshold to be able to extract this galamsey or illegal mining sites. And so the dark blue areas shows the extent of illegal mining for one of the years. And we realize that this illegal mining causes a lot of threat to the community members. It ends up polluting the water bodies as a result of the mercury deposits. So some people end up losing their lives, and then we are also losing a lot of trees. So, and another thing too is that these areas are quite inaccessible. So the best thing to be able to monitor this was to just assess these areas using satellite images. And another thing too we have done is that we created an app, a mobile app, to be able to use as a validation or reporting platform so that members or people who are able to access these areas will just update us on our server so that we will know the specific areas that are really illegal mining sites or not. Thank you.
Just to be clear, or just to be clear, this area, is it water or is it illegal mining?
That's illegal mining.
That's illegal mining.
Yes.
Look how much there is. There's a lot of it, right? Yeah. And if you could, thank you. So if you look at the series of tools that you could look at that have been built on top of Earth Engine technologies, there's a whole series of them. So during the breakout session, please feel free to ask about any of these. Okay. Thank you, guys. Eastern and Southern Africa. You ready? Come on, Steve.
Okay, so I'm Steve, a geospatial engineer. We work within RCMRD under Servir with 22 countries in Africa. There's a whole bunch of there's a whole bunch of tools that we've created, and I would say ever since 2017 we've been using Google Earth Engine to create most of the products for the services. But the biggest service that we've done on Google Earth Engine is this one. So when you hear about Space to Village, this tool actually really brings it down to that. We, in collaboration with the government of Rwanda, actually came up with this tool, the Rwanda Land Use Decision Support System, to actually manage all the affairs of what the country is doing to actually push their development forward to the sustainable development goals, which we hope to achieve globally. So basically what they did is they have a bunch of layers. They were really concentrated about stuff with landslide, land cover change, forest degradation, and they wanted a vulnerability map to be created out of that so that they can make decisions over where do they relocate people to, where do they take, which pieces of land do they actually focus and change them back to get reforested, and which areas do they actually start practicing crop farming on them. So previously, they used to use statistical data, basically tabular data, no spatial information from that. But then using this tool, which we actually gave it to them officially in May this year, I'm also hoping to look, and I'll be writing papers and articles and tweeting about all the changes that Rwanda does using this tool. So thank you.
Thank you. What is red? What is yellow? What is blue? Is blue mining?
No. This is the this is just one of the layers. Later on, we'll show you. We have brochures and the links for this. Later on, if we could meet later, this is the just woody cover changes. It's one of the layers that they are actually concentrated on. I know you can't see the different layers on here, but this is deforestation, degradation, minor loss, minor gain, growth. Others that have actually been blocked here. But then you can open the yeah. But then you can open up this link. Yeah, you could open up this link or see me afterwards. Let me not buy time into the other guys who are gonna speak. But me and Alan has brochures of all the services of the things that we've done. And feel free to see me look at this and ways in which you can implement in any country that you're interested in. Okay, thanks.
Thank you, Steve. The Himalaya Hindu Kush team. Here's the deep. Or you could use this if you're going to walk. Use this one. Okay.
Good morning, everyone. I'm Sudeep Pradhan, and me and my colleague Kabiruddin, we are from Hindu Kush Himalaya Hub. Actually, if you are looking at the green patch there, so it's a Hindu Kush Himalaya. Uh, so it's a mountains regions. We are based in our hub, Hindu Kush Himalaya, is based in Isimot, and we are working for 8 different member countries from Afghanistan, India, Pakistan, Myanmar, Bangladesh, Bhutan, China, and Nepal. And we use Google Earth Engine for various different apps, various service areas. Land cover is one of them. Also flood mapping, uh, and then my colleague will be talking more about our application of Google Earth Engine in wheat area mapping in Afghanistan, and we also do the lots of capacity building program in our member countries, actually teaching folks how to use Google Earth Engine.
Thank you, Sudeep. My name is Kabiruddin. I'm working as a GIS and remote sensing specialist. Uh, wait, I'll change. uh, uh, as Sudeep was mentioning, this large area, and today morning you have seen one presentation of how they are climbing. It's mountain region. It's not easy to climb or going those area easily. And if you see also IPCC report, they are used to say mountain region is a special data gaps. So under the Servir, we are working. Those are the land cover mapping, as Sudeep was mentioning a bit earlier. But nowadays, what demand day by day coming, we need some information is annual basis. But desktop basis, when we are doing, it was very much challenging for us. But when Google Earth Engine came, and this became a very much easy for us. And also, when we see the David Saah's presentation, he was mentioning about the service area. We are working for our research, or we are using for use. One of the important things for us to when we are working, we are closely working with government. So we are not developing, okay, please take it and use this. We are not doing. We are always together, okay. In the workshop, we are together. When we are define the need of this, we are together. We are maybe coding together, but we are maybe someone doing coding more, but someone always from their local knowledge, they are always this. So as one example we are going to show in Afghanistan. Afghanistan, one of the 80% people depending on the staple food is wheat, and landlocked country also. If they are not estimating their wheat production, wheat sown area is very challenging for them. So under the survey, we develop one tools, very much close collaboration with the Ministry of Agriculture and Livestock. And they are well trained actually. This system in the code base they can run to monitoring their wheat growing area. And beside here is some few things has been applied, like understanding the crop showing area, like crop calendar, phenology, and all aspect being considered, and it's well accepted by Afghanistan ministry. So with that, actually, thank you so much.
We also put together an app for normal users who can select a district and get the statistics. By the way, it's App Engine app.
Thank you, guys. Amazonia. Come on up. So you can kind of, as they're walking up, you can kind of see the spectrum and breadth of the different sorts of things we're working on. And we're just giving you some of the highlights. When you actually, if you were interested in some of them, you could talk to the individual groups, and they'll give you a more detailed list, okay?
Hi. So the Amazonia Hub is a little bit newer. We're 6 months old. So we're just in the stages of doing our user engagement, but we have a couple of first-year services that we're developing. So the first one is building on Terra I, which, do you want to say a bit about Terra I, and then I'll talk about the phase 2? Okay.
Okay, Terra I is a monitoring system to analyze land use cover chains and deforestation. We want to analyze it and use Google Earth Engine and TensorFlow to classify different crops in the Amazon. And currently, we have tools available. Is the
Conservación Amazónica ACA is available, analyzes the deforestation. It's a near real-time monitoring deforestation. They have a lot of examples and they use a high-resolution imagery and Sentinel to analyze it, for example, fires and deforestation in the Brasilia. They create a simple app to analyze the focus of fires and deforestation. This is the link available. And I'm working with a Terra project. It's a monitoring system to detect deforestation. We have the available dataset on the tropics. And Sipal.
Yeah. And then the last service that we'll showcase is we've been working with the Ministry of Environment in Ecuador in partnership with FAO, so UN FAO, to move some of those common scripts that we've all been learning about to track forest loss or forest degradation from the Earth Engine scripting environment into a GUI that's specific for monitoring your forest lands for greenhouse gas reporting. So the app is called Sepal, and it's sepal.io. And we've moved, and the big we here is FAO and Servir, have moved some of these applications into this platform. So for those of you that went to like the Area 2 estimator this morning, there's a GUI built around those in Sepal. You can do deforestation using the app in Sepal. And then we started building some degradation applications and moving it in here and linking it up with Collect Earth Online as well, which is what the Mekong Hub already presented. So this is an example where you can do some of the sample design to place your points to do area estimates of your forest loss layers, build that within Sepal, and then, the next slide that's not there would be moving it into Collect Earth Online. So we're starting to integrate some of these pieces and make it a little bit easier for countries looking at reporting their greenhouse gas emissions to just use one tool and have all of these connections already pre-made for you. So.
So before we move into the cafe style, I just want to say a couple additional things about Servir. So one thing is, a common question that we hear is, how do we get involved? You guys are working in an area that we're working in, and we'd like to collaborate. We are very open to that. If there is anything that you think is complementary or that could help lead to an impact on the ground, feel free to reach out to us, and we will lock you into the appropriate hub, the appropriate contact person. Tim raised your hand. Emil raised your hand. Those are our NASA folks. Most people know Emil via Twitter. Tweet at him, please, and also friend him. Follow him. What's the proper word? Follow him. Thank you. And we'll connect you in. The other common question that we hear quite a bit about is, hey, is that, I've said this a few times, I want to say it a few more times, can we actually gain access to your code or your applications? Yes, please take it. And there's a variety of different ways that we actually distribute it. Some feedback would be nice if you do take something, if you improve on it, please let us know so we can improve it for the regular system. Or if there's a better distribution method of how do we share code in a way that's better than GitHub. GitHub seems to work really well for programmer types of folks, but what we're also noticing is that people are also asking to transfer some of these tools to their regions, not necessarily the code to build it themselves, but the application to use themselves. That's a new common request that we're hearing. So if you hear about that as well and you have some grand ideas about that, please let us know. Are there any other general questions before we break out into groups? Yes.
So Dave, since you've been kind of, and again, just for people.
Can you come up here and talk through here?
It's a question for you.
Because they're recording.
All right.
I'm just trying to follow the rules.
All right. So just a question for you, Dave. So since you were really you connecting with Nick and with the Google Earth Engine team, Tyler, Noel, all the great folks, etc. And also Jamie, who's shout out to Jamie Favors here from NASA headquarters. He's the partnerships lead at the ESD level. Could you tell us just a little bit, because some people might be interested in knowing kind of why you thought hey, Earth Engine is something that the Servir network could take advantage of. Could you maybe speak a little bit to that?
Sure. Yeah, definitely. So you guys heard us talking a little bit about this being a needs-driven program. Service, co-development, all these fancy words, right? And it's all true. And the first step in all of this process is finding local collaborators who could actually use this stuff and make a difference. And when we do that, the idea is to go through and try to identify all those barriers to entry that is currently preventing them from actually using Earth observations to make an impact. That's our goal. And what we found was that, hey, there's a limitation in terms of access to data. There's a limitation in terms of understanding Earth observations and remote sensing, what you could do with it. There's a limitation in terms of compute. There's a limitation in terms of collaboration. How do you share this stuff? And when we went out there and we started looking at all the different technologies and solutions and approaches, at that time, Earth Engine was just getting going, and it was a natural fit. It eliminated a lot of the barriers and gaps that we had in order to be able to do that co-development process with folks on the ground. It allowed us to get to the science quickly, right? The questions quickly, without all that overhead up front. That was not a planted question, was it?
Maybe since maybe I could just put Jamie on the spot too.
Wait, microphone, please.
Maybe we could just also, just for people's general knowledge, since again Servir is a program within the capacity building program at NASA. Could you maybe talk a little bit about the partnership between NASA and Google?
Yeah, I mean, so. Oh, I only went part of the way up. At what point do I get into the camera?
Come. You're good. Stop.
Further in. Okay. So in general, I mean, I think we're just NASA trying to get better at, we do really well partnering with academic institutions, people doing research outright that are used to downloading NetCDF and unpacking data sets. By working with the commercial groups, is trying to understand where there's other opportunities. So we're doing work on the Earth side, doing storage and Voyager. You probably saw some of those last night. A lot of work on the Earth Engine side now, which is the data sets. But there's programs like Servir that don't have to go through this process of a large-scale partnership that can do very specific program-related things. So,
thank you.
Thank you.
How many stickers do you want?
Not planted question. Could we maybe put Tyler on the spot from the Earth Engine team? And again, thanks everybody. Big round of applause for Tyler and the great work that their team is doing. Could you maybe tell us a little bit about your perspective on, again, working with diverse user groups like the Servir hubs?
Yeah, I guess I could. I mean, we're very excited to have a group like Servir making such good use of the tools that we've developed, because our reason for building them in the first place is trying to enable this type of impact on the world. And I find that it has a sort of a multiplicative effect. If you find a group that works together, that can support each other from a programming standpoint, they can move much faster than just individuals that are maybe doing this research in academia, founded on their own, but they're working alone. So I think that is what I've been really impressed with the Servir group, is just seeing that there's so much collaboration going on within the group that they're really willing to share outside as well. And I think that's why they've been able to make such rapid progress. So we're really happy, actually, with what we see come out of Servir. Yeah.
What other surprises do you got for us, Emil? That's good. All right. Are there any other general questions? I really want to break you guys out so you could actually start digging in and getting stuff. That's what I'm really excited about.